Hello, today I'm going to work through a set of questions that you might typically get in an AS level physics exam on classical mechanics. The key formula that we shall use, and which you can find in my videos on various aspects of classical mechanics in the A-level physics playlist, are V equals U plus AT, S equals UT plus half AT squared, V squared equals U squared plus 2AS, kinetic energy is half mv squared, potential energy is mgh, work done is force times distance, power is work or energy divided by time, and that is the same since work is force times distance, then force times distance divided by time is the same as force times velocity. And rho, density, is mass over volume. In all these examples we shall use the gravitational acceleration as 9.81 meters per second squared. Question 1. We drop an object over a cliff. It falls for 5 seconds. And the question is, what is the maximum velocity at the end of the 5 seconds and how far does it travel? Well, we know that u, which is the initial velocity, is 0 because we drop it off the end of a cliff. We know the acceleration because that is g, 9.81. We know the time, that was 5 seconds, and we're asked to find the velocity at the end of that 5 seconds. So the formula we're going to use is one which combines these, which is v equals u plus at. V is what we're trying to find, u is 0, and then gravity is 9.81, but in all these things we have to decide on the positive direction, and I'm going to take upwards as being positive. So gravity is therefore minus 9.81 because it acts downwards, so it's minus 9.81 multiplied by the time, which is 5, and that gives you a velocity equal to minus 49.05 meters per second. And the minus simply tells you that the velocity, of course, is going downwards. So at the end of the 5 seconds, the article is travelling at 49.05 meters per second down. It's minus because the positive direction is up. To determine how far it travels, we need the formula S equals UT plus a half AT squared. S, of course, is the distance that we're trying to find. How far does it travel when it falls? And that equals, well, u is 0, so that gets nothing. Then we've got a half. A is gravity, which acts downwards, so once again it's 9.81 but a minus term. And t squared is t squared 25, so it's times 25. And if you work that out, you will find that that equals minus 122.625 meters. And again, the minus sign indicates that the distance is downwards because that's the direction of travel. Question 2. A car slows to a stop in 4 seconds and travels a distance of 50 meters. What was its initial velocity? What was its acceleration? Incidentally, acceleration, of course, is going to be deceleration because it's slowing down. Distance is speed times time, but the speed is constantly changing. So we can look for the average speed, and that gives us a formula that says that the distance travelled is going to be equal to u plus v divided by 2. That's the initial speed plus the final speed divided by 2 is the average speed multiplied by the time it takes to do so. 50 is the distance, 50 meters is the distance, is equal to u, which is what we're trying to find, the initial speed, plus v, well, it stops, so that's 0, divided by 2 times the time, which is 4 seconds. And that will give us a value of u equal to 100 divided by 4, and that's 25 meters per second. To find the acceleration, we're going to use the formula that v squared equals u squared plus 2as. V is the final velocity, which of course is 0. U is the initial velocity, which we've just discovered is 25, so it's 25 squared. Remember that g is a slowing acceleration, so that will be a minus term. So now you've got minus 2 times the acceleration, which is what we want to know, times the distance travelled, which is 50 metres. And that gives that minus 100A equals 25 squared, 625. And that means, of course, that A is minus 625 divided by 100, which is minus 6.25 metres per second squared. So minus tells you it's decelerating, which of course it must be because we're slowing down. Question 3. We have a stream which is flowing in this direction, and it's giving anything on it an acceleration of 7 metres per second squared. And we have a boat on the stream. What we're going to do is to push it initially in this direction, so it's going upstream against the current. And of course what will happen is it will travel for a certain distance, slow down, stop, and then it will travel downstream until it gets to a point which is 1 metre away from where it started. And I can tell you that when it gets to that point, it is travelling at 5 metres per second. And the thing we have to discover is, firstly, what is the initial velocity and what is the total distance that it travels between the far point upstream and the point downstream where we measure the velocity at 5 metres per second. Now I should just observe that this question is simply a variation in the horizontal direction of the more usual question in the vertical direction. This is exactly the same as saying I take a stone and I'm 1 metre above the ground, or at least the stone is, and I throw it up in the air. It will of course come to a stop and fall down again due to gravity and hit the ground, and I say that when it hits the ground it's travelling at 5 metres per second, and what we're asking is what is the initial velocity in that direction and what is the total distance covered. It's exactly the same question, it's just horizontal rather than vertical, and instead of gravity being 9.81, which it would be here, it's actually only 7 as far as the stream is concerned. Well, how are we going to start this? We need to find what u is, we know what v is, and so we're going to say that v squared equals u squared plus 2as. We know that v is 5, we don't know what u is, that's what we're trying to find, plus 2 times 7, because that's the acceleration, times the distance travelled. Now the distance travelled as far as we are concerned is 1 metre, because although the ship has actually gone all the way upstream and all the way back again, the actual distance covered is only 1 metre. You only take the net distance. If something goes up and back again, it's effectively travelled no distance at all. So the only distance actually travelled for the purposes of this formula is 1 metre. And so we have, sorry, that should be 5 squared. And so we have 25 is equal to u squared plus 2 times 7 is 14. Incidentally, what should be obvious is that I'm treating the downstream, or that direction, as the positive direction. And now I can get that u squared is equal to 25 minus 14, which of course is 11. And that means that u is, now when you take the square root of 11, you're going to get two answers, plus and minus 3.31 metres per second. What does plus and minus mean? Well, the answer that we obviously want is minus 3.31 metres per second, because that is the speed of the boat, the initial speed when it's going upstream against the positive direction, in the negative direction. But what does the positive value mean? Well, of course, when the boat gets here, it stops, and then it comes back again. And as it passes its initial point, it is once again doing 3.31 meters per second, but this time in the positive direction. So these two values, plus and minus 3.31, simply tell you the values of the velocity at this point. Firstly, the initial velocity when it's going in that direction, and then the velocity when it passes this point again, travelling in that direction. So that's the initial velocity. That was the first thing we were asked. The second thing we were asked is what is the total distance travelled upstream and then back downstream. Well, I know that distance is 1 metre, that's given to me, so I need to find this distance, the distance between the initial position of the boat and where the boat comes to rest upstream. And I'm once again going to use the formula v squared equals u squared plus 2as, but this time my initial velocity is going to be the one we just found, 3.31. The final velocity is the velocity at this point, which is 0, because it stops when it gets to this point and starts coming back the other way. So now we can say that v squared is 0 equals u squared. Well, we know what 3.31 squared is, it's 11, plus the 2 times the acceleration, which of course is 7, times the distance, which we don't know. That's what we're trying to find out. And that will give us a distance, s is equal to, it's technically minus 11 over 14, which equals minus 0.92 meters. And the reason that it's a minus is because that is measuring the distance from here to here, and that's going in the negative direction. So the signs kind of tell you which way you're going. And therefore, since this distance is 0.92 meters and this distance is 1 meter, the entire distance, which is what we were asked to calculate, the entire distance, which we'll call d, is going to be, we don't need to worry about the minus sign anymore because it's just a length, 1.92 meters. Question 4. A person is jumping on a trampoline and will jump to a maximum height of 4 meters. And what we want to know is what is the initial velocity, how long does it take, what is the time to reach the highest point, and what is the velocity when that person lands back on the trampoline. Once again, we're going to start with the formula v squared equals u squared plus 2as. When the person gets to the top of the jump, the velocity will be 0, because that's where they stop and start falling back down again. So 0 is equal to u squared, which is the initial velocity, which is what we're trying to find, plus 2 times gravity. Well, we're going to take upwards as the positive direction, so gravity is now times minus 9.81 times the distance, s, which is 4 meters. And that gives us that u squared is equal to 78.48 if you multiply these terms out, and that means that u equals plus or minus 8.86 meters per second. Now, what does that term actually mean? Why is it plus and minus? Well, it's plus 8.86 meters per second jumping upwards, but it is also the speed at which she is travelling, or he is travelling, when they return to the trampoline. So we've answered the third part of the question. The initial velocity is 8.86. They go all the way up, they stop, they come all the way back down again, and when they arrive back at the trampoline, they're travelling at 8.86 meters per second, but in the other direction. That's why you get a plus and minus term. To find how long it takes to get to the maximum height, we're going to use v equals u plus at. We know that maximum height v is 0 because that's where you stop and start coming back down again. We know that u is 8.86 in the positive direction because it's going upwards, plus A is now minus 9.81 and T is what we're trying to find. And that means that T is going to be 8.86 divided by 9.81. And that's about 0.9 seconds. So it takes 0.9 seconds to get from the platform, as it were, of the trampoline up to the top before you start coming back down again. Question 5. A person is standing on top of a cliff. The cliff is 600 meters high, and that person hits a ball initially entirely in the horizontal direction at 20 meters per second. And the question, what we want to know is how long will it be before that ball hits the ground, and how far will it travel? Obviously its trajectory, because gravity will pull it down, will be something like that. We want to know the time it takes before it hits the ground, and we want to know the range, the distance that it travels along the ground. Let's extend the ground there, along the ground before it hits the ground. We can look at the vertical and horizontal elements separately, and we're going to take upwards as being the positive direction. So let's start with the vertical component, and we're going to use the formula S equals ut plus a half at squared. Now the distance is going to be 600 meters, because that's how far it falls vertically. And that's going to equal, well, what is the initial vertical component of the velocity? 0, because the ball is actually hit horizontally. So the initial component is 0, plus a half. A, of course, is minus 9.81 because gravity acts downwards and the positive direction is upwards. And t squared, well, t is what we're trying to find. Well, that will give us, in fact, this is minus 600 because technically the distance is measured downwards and the positive direction is upwards. So now we get that t squared is equal to 600 times 2 divided by 9.81. And if you work that out, you'll get that as being 122.32, which means that t is equal to plus or minus 11.06 seconds. Now, in this case, the minus has very little purpose. You can't have a minus time. So it takes 11.06 seconds before the ball lands on the ground below. And now we need to know the range. Well, that of course is fairly simple because the horizontal component of the velocity will not change. It will still be 20 meters per second. The vertical component of the velocity is changing due to gravity, but the gravity will have no effect on the horizontal velocity, which remains 20 meters per second throughout. So what is distance? Distance is just velocity times time. Well, we know what the velocity is, so let's put that down. D is equal to the velocity times time. We know what the velocity is. It's 20 meters per second. We know what the time is. It's 11.06 seconds before it hits the ground. So it's 20 times 11.06. And 20 times 11.06 is 221.2 meters. So it travels 221.2 meters along before it hits the ground. Question 6. A person throws a ball from a height of 1 meter above the ground, and it will obviously follow a trajectory something like this. And I can tell you that the vertical component of the velocity of the ball is 40 meters per second, and the horizontal component is 50 meters per second. And what we are asked to find is, what is the maximum height of the ball above the ground? And the trick here, of course, is to remember that it starts 1 meter above the ground, and as usual I'm going to treat the upwards direction as the positive direction. I'm going to use the formula v squared equals u squared plus 2as, When the ball gets to this height here, its vertical velocity will be 0, because it's gone essentially vertically, it just goes up and down. Horizontally, of course, it travels at 50 meters per second throughout. But in fact, we won't even need this 50 value. That's irrelevant for our purposes. We only need the vertical component. So when it gets to the top of the curve, its vertical velocity is 0. So v is 0. U is its initial vertical velocity, which is 40, so it's 40 squared, plus 2 times gravity, which of course will be minus 9.81, times the distance, which is s. S is not h. H is s plus the 1 meter. We must remember that, don't get caught out. And that gives us that s is equal to 40 squared, which is 1600, divided by 2 times 9.81, and if you do that on the calculator you'll get 81.5 meters. So s is the distance from where the ball is thrown to the top of its trajectory. But that is 1 meter above the ground, and so the total distance h is 82.5 meters, because as we said, you have to add 1 meter to the distance s. Question 7. A skier is skiing downhill and is subject to an acceleration of 3 meters per second squared. And the question is, how far have they travelled from the initial starting point after 1, 2, 3, 4 and 5 seconds? So we need to find a distance s. We know the time because that's what we've been given. We know that u is 0 because the skier starts from scratch, and of course we know that the acceleration is gravity. So the correct formula here is s equals ut plus a half at squared. S is equal to, well, u is 0, so that just becomes 0, plus a half times the acceleration, which in this case is 3 meters per second, not gravity, because we've already been told that the skier's acceleration is subject to this, times t squared. So essentially the distance is equal to 1.5, that's half of 3, times t squared. So if you want to know, we'll just plot distance against time, or let's do it the other way round. Let's do time and the consequential distance, which is s. Gosh, what a mess that is. This is time, this is distance. And what we've been asked in the question is, what is the distance travelled after each of 1, 2, 3, 4 and 5 seconds? And the formula is quite simple. The distance is 1.5 times the square of the time. So you take the time, you square it, you multiply it by 1.5. So when t is 1, t squared is 1, and 1.5 times that is 1.5 meters. When t is 2, 2 squared is 4, 1.5 times that is 6 meters. When t is 3, t squared is 9, 1.5 times that is 13.5 meters. When t is 4, t squared is 16, 1.5 times that is 24 meters. When t is 5, t squared is 25, 1.5 times that is 37.5 meters. So what this tells you is the distance from the starting point, after 1, 2, 3, 4 and 5 seconds. Question 8. We have an aluminium cylinder. I can tell you that the radius of the cylinder is 5 centimeters and that the height of the cylinder is 7 centimeters and that the mass of the cylinder is 1495 grams. And the question is, what is the density of the aluminium of which this cylinder is made? What you have to remember is that the density is mass divided by volume, and that's going to be the mass, which is 1495 given, divided by the volume of a cylinder. The volume of a cylinder is simply the area of the circle multiplied by the height. So that's going to be pi r squared, that's the area of the circle, times the height. and that's going to equal 1495 divided by pi times r squared, which is 25, times the height, which is 7. And if you put that all into a calculator, you should find that rho, the density, is 2.72 grams per centimetre squared, centimetre cubed. That is not SI units, but it's a perfectly fair value to give. Grams per centimetre cubed for density is not unusual. The second part of the question is, what then would be the mass of a cube of aluminium of side 6 centimetres? Well, once again we would use the formula that rho is mass over volume, but now we are trying to find the mass because we already know the density. So mass is going to be density times volume. Density we know is 2.72 because we just calculated it, and the volume is 6 times 6 times 6, it's 6 cubed. And again, if you multiply that out on your calculator, you should find that that comes to 587.6 grams, and that's the mass of a cube of aluminium of side 6 centimetres. Question 9. A picture is hung on the wall. The picture weighs 10 kilograms. And it's hung on the wall with a piece of string over a nail, such that there will obviously be a tension in the string. And I can tell you that the two angles that I've just marked, theta, those two angles are each 30 degrees. And the question we are asked is, what is the tension in the string? And the way to tackle this is to resolve all the forces in the vertical direction. And obviously the forces must balance, because the picture does not fall off the wall, it doesn't accelerate off the wall, it stays put. So the net force must be 0. What are the forces that are acting upwards? Well, there are two tension. But the vertical component of the tension is not going to be T, but T times the sine of this angle. So it's T times the sine of 30 degrees. And there are two of them, because we've got two bits of string, each with tension T. So those are the two forces acting upwards, and that must equal the force acting downwards, which of course is going to be mg, so it's 10 is the mass, times 9.81, which is g. And sine 30, of course, I've chosen because that's nice and simple, that's a half, so half times 2 just becomes 1, and that means that T is equal to 10 times 9.81, which is 98.1 newtons. And this is intriguing because the actual mass of the picture is 10 kilograms, so the force acting downwards is 10 times g, which is 9.81. So the force acting down is 98.1 newtons, and yet in each of these strings you have got a force of 98.1 newtons. You've got twice the force effectively in those strings than you have the weight of the picture. Why is that? Because the forces are acting at an angle, and only the component acting vertically counts. So let's suppose that you arrange this picture frame such that the string had a much larger angle. This time you're going to hang the picture, as it were, like that, and the angle, instead of being 30, is now 60 degrees. How will that affect the tension in the string? Well, this formula will be the same, except that instead of sine of 30, we now need sine 60 is equal to 10 times 9.81. Sine of 60 is, of course, 0.866. And if you multiply that out, you get that T is equal to 10 times 9.81 divided by 2 times sine 60, and that comes to 56.6 newtons. So what you find is, if you make the angle steeper, or narrower or larger, make the angle larger, there is not so much tension in the string. So if you don't want the string to break, it's a good idea to have a much bigger angle. If you have a narrow angle, you'll have more tension in the string, more likelihood that it will break. Question 10. Two people are trying to pull a very heavy object. That's the very heavy object. One person is pulling it vertically, or actually let's say in this direction, with 600 newtons force. And one person is pulling it in that direction with 1000 newtons force. And the question we are asked is, what is the resultant force and what angle will it be to the x-axis? I'm thinking of the x-axis as being the horizontal axis. Well, we know that when we've got forces acting in this way from a common point, the way to find the resultant is just to complete the oblong, and then the resultant is the diagonal. That is the resultant. That is R. And Pythagoras tells you this, of course, is 1000 and this is 600 from this diagram here. Pythagoras tells you that R squared is going to be equal to 1000 squared plus 600 squared. And if you work that out, you will find that R is equal to 1166 newtons. So that is the resultant force. What is that angle? Well, that's quite simple. The tangent of that angle, tangent of theta, is going to be this side over this side. This side is 600. This side is 1000. So in other words, it's 0.6. And when tangent of theta is 0.6, you'll find that theta is 31 degrees. Question 11. I'm trying to unlock a rather tough wheel nut, and I'm going to use a spanner which is a two-handed spanner, and the torque, I can tell you, is equal to 50 Newton meters. And the question is, what force do I have to apply at both ends in order to get that nut untightened? And we remember that torque is equal to the force times the distance. And I can tell you that this distance here, in other words the complete length of the spanner, is 0.5 meters. Well, we've got a force acting up here, which we don't know the value of, we'll call it F, and we've got a force down here which will be the same force but in the opposite direction. So we've got a force acting at a distance 0.25 meters because it's only half to the point of turning, and we've got another one here acting at a distance of 0.25 meters. So we've got two lots of force acting at 0.25 meters, and that's the total torque, and that equals 50. That's what we were given. And that means that 0.25 F is equal to 25, which means that F is equal to 100 newtons. So the total force needed on both sides of the spanner is 100 newtons. Question 12. The person is on a diving board which is 2.5 meters away from the pivot point of the diving board, and that person has a mass of 80 kilograms. And the question is, what is the moment about this pivot point, which we'll call point A? The moment is going to be the force times the distance. The force acting downwards is going to be the mass times the gravity, which is 9.81, times the distance, which is 2.5 meters. And that will give you a total of 1962 newtons. The second part of the question is, if this person dives off the diving board and jumps down a distance of 3 meters into a swimming pool, what will their speed be on entering the water? And for this we recognise that potential energy on the diving board will be converted into kinetic energy by the time you're about to hit the water. Potential energy is mgh, and that is equal to and will become kinetic energy, which is a half mv squared. You'll notice that the m's cancel out, And so you will get that V squared is equal to 2 times G times H, which is 2 times 9.81 times the height, which was 3 meters. And that gives you that V squared is equal to 58.86. And therefore V is equal to, well, it's plus or minus, but for the purposes of this calculation, that doesn't really matter. It's 7.67 meters per second. That is the velocity that this swimmer is going to have when they get to the water 3 meters below the diving board. Question 13. A ship is travelling across a river. It's going across the river. The engine has a force of 500 newtons. The water is causing a drag, and the drag factor is 100 newtons. And the flow of the river is such that there is a force of 300 newtons carrying an object downstream. What we want to know is, what is the resultant force and what is the resultant acceleration of the ship? Well, the way we do this is to treat the vertical and the horizontal, or as it were, this direction and this direction. It's not vertical, of course, because we're essentially looking down on the ship, so it's north-south or east-west. So first we'll consider forces in the north-south direction. Well, we've got 500 going in that direction, and we've got 100 coming in this direction, so that becomes minus 100, and that's 400, a net force of 400 in the north direction. As far as the forces in the east-west direction are concerned, there's only one. It's 300 newtons, and it's in that direction. So those are our two resultant forces. Essentially, we've got a force of 400 going north, we've got a force of 300 going west, if you like, and the resultant will be R. And once again, we use Pythagoras to calculate R. R squared is going to be 400 squared plus 300 squared. And if you work that out, you'll find, of course, this is essentially a 3, 4, 5 triangle, so you don't really need to do it. R equals 500 newtons. We're not actually asked what the angle is, but if we were, it would be pretty simple. The tangent of that angle would be 3 over 4, 3/4, so tangent of theta is 0.75. That will tell you what angle away from the north direction, which the ship is trying to sail in, it will eventually be pushed. But we are asked about the acceleration, and for that we need to say that F is equal to ma, force is mass times acceleration, which means acceleration is force divided by mass. The net force we've just calculated is 500 newtons, and the mass of the ship, I can tell you, is 300 kilograms. And that will give you a net acceleration. 500 divided by 300 is 1.66 meters per second squared. So the ship will accelerate at that rate as it is trying to cross the river. Question 14. A car is driving along a road and it is travelling at 12.5 meters per second. When suddenly a dog runs out, and that dog is 15 meters away. The driver's reaction time is 0.5 seconds. The braking force of the car is 12,000 newtons, and the mass of the car is 1,000 kilograms. And we are asked the following. What is the speed of the car in miles per hour? How far does the car travel during the thinking time before the brake is applied? How far does it travel after the brake is applied? And finally, will the car hit the dog? We'll make an assumption that 1,500 meters is equal to 1 mile. So 12.5 meters per second, which is the speed of the car, is equal to 12.5 divided by 1500 miles per second, but then there are 3,600 seconds per hour, so that is the speed in miles per hour. And if you calculate that, you should find that comes to 30 miles per hour, which is the speed limit in the UK in towns and cities. The second part of the question was, how far does the car travel during the thinking time before the brake is applied? The thinking time is 0.5 seconds, so the distance travelled during the thinking time, which I'll call dt for thinking, is simply going to be the speed times the time. The speed is 12.5 meters per second times the time, which is 0.5, and that equals 6.25 meters. So of our 15 meters, we've travelled 6.25 meters before the brake is even applied. The next question is, how far does it then travel once the brake is applied? Well, to find the deceleration, we need the formula F equals ma, and that means that A is F over m. I told you that the braking force is 12,000 newtons and the mass is 1,000 kilograms. So this is going to be 12,000 newtons divided by 1,000 kilograms, and that's going to give us a deceleration of minus 12 meters per second squared, because we're slowing down. And now we can apply that to the formula v squared equals u squared plus 2as. We know that v, the final velocity, is 0 because that's when the car stops. We know that u is 12.5 because that's the initial speed of the car, so that's squared, plus 2 times, the acceleration is minus 12, times the distance, which is what we're trying to find. We'll call this ds, the stopping distance. And if you simply put all that into your calculator, you'll find that ds is equal to 6.5 meters. So it will stop in a further 6.5 meters. So the total distance, d total, is going to be the thinking distance, 6.25 meters, plus the stopping distance, 6.5 meters, and that is equal to 12.75 meters. And I'm happy to tell you that that means you will stop 2.25 meters before you get to the dog. So the dog happily will be safe. Question 15. A car smashes into a wall at 20 meters per second. And the stopping time is 0.1 seconds. The mass of the car is 1,000 kilograms. We want to know what is the force acting on the car as it hits the wall. Well, we know that V equals U plus AT. V is 0 because that means the car stops. U is the initial speed, which is 20 meters per second, plus the deceleration, which we don't yet know, times the time, which is 0.1 seconds. And that will give us an acceleration, or this will be actually a deceleration, of minus 200 meters per second squared. The minus tells us that it's a deceleration. Force is then equal to mass times acceleration. The mass I told you was 1,000 kilograms, so that's 1,000 times the acceleration we've just found, which is minus 200, and that's going to be minus 200,000 newtons. So the force on the car when it smashes into the wall is minus 200,000 newtons. And you can see that that is influenced by the amount of time it took for the car to stop. That's the reason cars have crumple zones, because when the car is crumpling, it takes longer to stop. and if it takes longer to stop, then the acceleration will not be so high, and that means the forces applying will not be so large, and it's the forces that do the damage to you. So if you can reduce the forces when the car hits something, you significantly reduce the risks to yourself. So crumple zones are designed to increase the collision time, so it takes longer to get to zero, and that means the forces are significantly less. Question 16. A barge is being towed along a canal by a horse, and I can tell you that the boat is travelling at 1 metre per second. There is a rope connected to the boat, that the tension in that rope is 100 newtons, and that the angle of that rope, theta, between the rope and the direction of travel is 30 degrees. I can tell you that we're going a distance of 1,000 meters, and the question is, what is the work done and what is the power? Well, work is force times distance. The force is 100 newtons, but that's in this direction. We need to know what is the relevant force in this direction, the moving direction. So that's going to be 100 times sine of the angle, which is 30. Sorry, not the sine, the cosine of the angle. That the component of the force, 100 newtons in that direction, is 100 times the cosine of the angle 30, multiplied by the distance travelled, which is 1,000 meters. Cosine 30, of course, is 0.866, and so you will find that that means that the work done is 86,600 joules. What is the power? Power, as I set out in the formula that I used at the beginning, is force times velocity. Just a reminder, power is work done divided by time, t. Work is force times distance divided by t, and distance divided by time is velocity. So that's how we get that. And that means that the power is equal to the force, which once again is 100 times the cosine of 30, multiplied by the velocity, which I told you was 1 metre per second. So this is all times 1, and that will get you 86.6 watts. Question 17. I'm going to pull up a total mass of 20 kilograms over a distance 3 meters, and I'm going to do so with a velocity of 0.25 meters per second. And the question is, what is the work done and what is the power? Well, the work done is going to be force times distance. The force that I'm going to have to use is the force, it's essentially opposing the force that's acting downwards, and that's going to be 20 times g, mg, so 20 times 9.81 is the force, times the distance, 3 meters, and that comes to 588.6 joules. And then power is force times velocity, which again is going to be 20 times 9.81, that's mg, the mass times gravity, which essentially I am opposing by pulling it upwards, multiplied this time by the velocity, which is 0.25, and that's going to give you 49.05 watts. 49.05 watts. Question 18. A skateboarder is inside what is essentially a semicircle on his skateboard, and I can tell you that the total height is 2 meters, And the question I want to know is, what is the velocity of the skateboarder as that skateboarder comes past the lowest point? And how far up the other side will the skateboarder travel? In other words, what is the distance d that the skateboarder will get to on the other side of the, as it were, semicircle? For this, we need to recognize that potential energy will be converted into kinetic energy, and we'll assume that it's 100% efficient. Of course, it won't be because there'll be friction, but we'll forget about that. And that means that mgh will convert into half mv squared. The m's cancel, and you're left with the fact that v squared is equal to 2 times g times h. And that is equal to, that's when it's at its lowest point, that will be 2 times 9.81 times the height, which is 2 meters. And that will give you a velocity of 6.26 meters per second. It's plus or minus, of course, but that doesn't really matter because we know that it is traveling in this direction. The skateboarder is coming down, starting at 0, with a potential energy, mgh, that is converted to a half mv squared by the time the skateboarder gets to the bottom, where h is the 2 meter distance vertically that he's come down. The other part of the question was, how far up the other side will the skateboarder go? Well, the answer is that, of course, now the kinetic energy will convert back to potential energy. And if we assume that there's 100% efficiency, then the skateboarder will go all the way back up to the same height that they started. Actually, of course, in practice, some of that energy will have been lost in friction, so they will actually only go up to a much lesser height. But if we're assuming 100% efficiency, then the kinetic energy will convert back into potential energy, and they'll go all the way back up to where they started. And the final question, question 19 for this video is, I'm going to drop a ball from a height of 10 meters, and I'm going to tell you that it will bounce back again to a height of 7 meters, and the mass of the ball is 50 grams. And the question is, what is the kinetic energy when the ball reaches the ground, and what is the energy lost in the bounce? Well, once again, we know that potential energy will be converted into kinetic energy, which means that mgh will be a half mv squared. And that means that the m's cancel. Although, in fact, I'm being asked, what is the kinetic energy? So actually, the kinetic energy is that whole term. So the kinetic energy will be mgh, because mgh, the potential energy, will be wholly converted into into kinetic energy, and mgh is the mass of the ball, which we have to express in kilograms. So I think that's 0.05 kilograms, multiplied by g, which is 9.81, multiplied by the height, which is 10 meters. And that comes to 4.905 joules. So the kinetic energy, which is what we were asked for at the point where the ball is about to hit the ground, is 4.905 joules. You could have also calculated the velocity, which is the way I was going to do it, by saying that v squared equals 2gh. You know that g is 9.81, you know that h is 10 meters, so you could have calculated the velocity as well. Now, when the ball goes back up to this height, 7 meters higher, it will acquire potential energy. And the potential energy on the route up is going to be mgh again. And that's going to be the mass, which is 0.05 kilograms, times gravity, 9.81, times the height, which is now 7. And if you multiply that, you'll get 3.434 joules. So that is the potential energy when the ball gets back up here. It had kinetic energy of 4.905 joules just before it hit the ground, but when it bounced back up, it gave a potential energy of only 3.434. So the difference between these two amounts is the kinetic energy that was lost, and that means that the lost energy is equal to the difference of these two, which is 1.471 joules was lost, and that would be lost in terms of heat and sound as the ball hit the ground.